Hello again, friends. I hope you are all in a good health condition. Today's lecture in 3.3, Chapter 3, Section 3 is about horizontal and vertical asymptotes. It's a subject away from the other two sections because in the other two sections, 3.1 and 3.2, we generally talked about increasing functions in Section 1, decreasing functions, critical numbers, and relative extrema. But in section 2, we talked about concavity and inflection points. So in those two subjects, in section 1, in general, when we were talking about increasing, decreasing, critical numbers, relative extrema, in general, as we said, we were depending on f prime, the first derivative of the function. We were working on the first derivative of the function to find those stuff. For concavity and inflection points, we were using the second derivative of the function for finding the concavity and inflection points. And of course, we've got examples mixing both of them together. You have to be aware of which derivative you are using. And that was all about section 1 and 2. In section 3, we've got horizontal and vertical asymptotes. In the course material, vertical asymptotes are explained first, but I will do the horizontal asymptote because it will make it easier for you to understand. Okay, what is a horizontal asymptote? A horizontal asymptote, it's a line, okay? So we say that, let me write the definition for you. A horizontal asymptote, it is a line, a horizontal line, okay? A horizontal line, y that's equal to b, is called a horizontal, okay, asymptote for the graph of y that's equal to f of x if, what's the condition? Limit of f of x as x is approaching to infinity is equal to b, or limit of the function f of x when x is approaching to negative infinity is equal to b. So what do we have in general? Okay, that was the definition. Let us come to the explanation. What do we have? We have got a function f of x that is given to us, okay? What is a horizontal asymptote? It's a horizontal line, y that's equal to b. How do we find that y equal to b? We are using the concept of limit. If you find the limit of that function as x is approaching to infinity, and the result is a number, okay, a number b, I call it here b, you can write it a, b, e, c, or doesn't make a difference. Or when x is approaching to negative infinity, and the result is equal to b, we call that b, okay, a horizontal asymptote. Okay, a horizontal asymptote. Okay, so that's the procedure for finding a horizontal asymptote. Let's do the first example that is given in the course material. It says, of course, example 3.3.2, okay, it says determine all horizontal asymptotes of f of x that's equal to x squared over x squared plus x plus 1. So what's given to us here? We are given the function f of x that's equal to x squared over x squared plus x plus 1. It's required from us to find the horizontal asymptote of that function. How do we find the horizontal asymptote for that function? We are using that concept of limit. We are, of course, finding the limit of x as it is approaching to infinity, and we are finding the limit of that function as x is approaching to negative infinity. We are doing both of the cases. The numbers that we get from those ones, from the result of the limit, we will call that numbers that constant's horizontal asymptote for the function. Okay, so let's do this one. Limit of x as this approaching to infinity, x squared over x squared plus x plus 1. Okay, how do you find that limit? We have got a condition for finding limit as x is approaching to infinity. We have studied those conditions. We are looking at the highest power of the denominator. Okay, we are looking at the highest, let me write it for you, highest power of denominator. As we talked about when we were explaining limits, we don't care about the power of the numerator, even if it is higher than the power of the denominator. We just care about the power of the denominator. So what is the highest power of denominator? It is x squared. Okay, x squared. If you look at the denominator, it is x squared. So what we're gonna do, we're gonna divide every term in that function, okay, x squared divided by x squared. Why? Because the highest power of the denominator is x squared. So I'm dividing every term by x squared. Let's see what we will get. If I'm doing that limit, I will get, okay, that's equal to limit of x as this approaching to infinity. Let me come to that side again, sorry for that. X squared divided by x squared, it is equal to 1. Okay, x squared again divided by x squared is equal to 1 plus x divided by x squared is 1 over x. So that will be 1 plus 1 over x plus 1 over x squared. Why? Because here I have got 1 over x squared. There is no cancellation, so I will leave it like that. Let's calculate that limit. The limit of 1 is equal to what? It's equal to 1. Limit of x as this approaching to infinity of 1, it's again equal to 1. Limit of 1 over x as x is approaching to infinity, we have studied this one, that's equal to 0. And limit of 1 over x squared as x is approaching to infinity, that's also equal to 0. So in general, if you look at that limit, it's equal to what? 1 over 1 plus 0, 0. 0, 0 plus 1 is equal to 1. So that will be 1 over 1. Okay, and that's equal to 1. What did I get here? I got the number 1. Okay, what does the formula say? Well, the definition of horizontal asymptote, it says if I find the limit of the function as x is approaching to infinity and that's equal to a number, I will call that number a horizontal asymptote. So I found the limit of the function and I got the number b. Okay, that's the number b that I got. So I will call that be what? A horizontal asymptote for the function. So I will write y is equal to 1. Okay, that number here is a horizontal asymptote for f of x, or f, whatever you want to write. That's the first case. Let's do the other case. Okay, that's limit as x is approaching to infinity. How about limit as x is approaching to negative infinity? Let us see if it is equal to a number or not. Maybe we get the same number, maybe we are not getting anything. Let us see. Okay, limit of x as as x is approaching to negative infinity of x squared over x squared plus x plus 1. That's the same function because we are dealing with the same function. Okay, in the previous one, what was the procedure we did? We were looking for the highest power of the denominator, that's equal to x squared, dividing all the terms by x squared. We got that one. Here you can do the same procedure. The highest power here is what? Of the denominator is again x squared. Okay, because when x is approaching to infinity or negative infinity, that's the procedure we are doing for the limits. Okay, so x squared divided by x squared is equal to 1. X squared divided by x squared is again equal to 1. X divided by x squared is equal to 1 over x, like we did previously, and x is approaching to negative infinity, that will equal to 0, and that one is also 0. So what is that limit equal to? Again, we calculated it. That's equal to 1. What did we get again? We got that number. We got the same number. It doesn't make a difference if you get the same number, another number. The important is that if you get a number, that number will be the horizontal asymptote for the function that we have got. So again, we got the same number. So in general, y equal to 1 is a horizontal asymptote for f of x. Okay, so how many horizontal asymptotes do we have? We have got only one horizontal asymptote because we calculated limit as x is approaching to infinity, we got one. Limit of x as it is approaching to negative infinity, again we got one. So they are both equal, even if they are not equal, of course, where we get that this is the horizontal asymptote for the function. Another way for finding that limitation of x as it is approaching to infinity, you have studied this one. You always call it trig or whatever you're calling it. If I have got limit of x as it is approaching to infinity, I will do it with the same function, okay? X squared plus x plus 1. That's another way for finding that limit. You have studied this one. If the power of numerator and denominator are the same, we are taking their coefficients. Okay, what's the coefficient? If you look at the numerator, it is x squared, and the highest power in the denominator, it is x squared. Without doing those steps, okay, we can guess that that limit is equal to what? The coefficient of this one is equal to 1. The coefficient of denominator is equal to 1, so that's equal to 1. But you have to write the cos for me. What is the cos? The cos is that since we are writing since the power of numerator and denominator are the same. Okay, as I've told you, if you're not writing the cos for me, you will not get the marks that you want. Okay, so that was about limits. Let me give another example about that, although there are no more examples given about horizontal asymptotes in the course material, but we will write another example here. Okay, again, determine the horizontal asymptotes of if f of x is given to you as for example 3x squared plus x over x squared, or let me say 2x squared minus 1. Okay, if you look at that function, what do we have? What is required from us? Finding the horizontal asymptote. So what do we have to find? We have to find the limit of x as it is approaching to infinity or negative infinity. I'm finding both of them together because it gives me the same result, but we have to do it separately like we did for the previous example. So that is 3x squared plus x over 2x squared minus 1. Okay, if you look at this one, I will do it like this way, okay, not that way. Of course, if you do it this way also, you will get the same result, but that one is easier. Okay, if you look at the power of the numerator, the highest power is x squared. If you look at the power of the denominator, the highest power is x squared. Since the power, again, the power of the numerator and denominator are the same, so we are taking their coefficients. What is that equal to? That's equal to 3 over 2. What did I get? I got a number. Okay, since that one is the number that I want, because we said if we find the limit of that function and if we get a number, okay, that number will be what? That number, y is equal to 3 over 2, will be the horizontal asymptote for the function f of x. Okay, I'll give you another example. Again, find the horizontal asymptote of f if it exists. Okay, because we may not find any horizontal asymptotes. F of x is given to us as, for example, let us say x to the power of 3 over x squared plus 1. Okay. Let's find the solution. What do we have to find? We have to find limit of x as this approaching to infinity once for the function. Okay, x squared plus 1. And also we have to find limit of x as this approaching to negative infinity. Okay, of the same function. Let's see what we will get. If I look at this function, what do I have? The highest power of the denominator, I have got x squared. So I will divide all of the terms by x squared. What will I get? I will get that limit is equal to what? Limit of x as this approaching to infinity, x cubed over x squared is equal to x. X squared over x squared is equal to 1 plus, and the other term is equal to 1 over x squared. Limit of x as this approaching to infinity for 1 over x squared is equal to 0. We have studied this one. Limit of x as this approaching to infinity for x that's equal to infinity, because I'm directly inputting this one into here instead of x, so I will get infinity. So in general, if you look at that expression here, what do I have? I have got infinity over 1. Infinity over 1 is equal to what? Infinity over 1, that's equal to infinity. Is that a number? No, it's not a number. It is equal to infinity. So here, in that case, I have got no horizontal asymptote. Let me check for this one. Why? Because the definition says this one or that one. So if you didn't get anything from the limit as x is approaching to infinity, we may find something as x is approaching to minus infinity. If we also didn't find anything here, so in general, we're saying that it doesn't have any horizontal asymptote. Or if you found anything, so of course it will be a horizontal asymptote. Again, if you look at that function here, what do I have? The highest power of the denominator, I have got x squared. Okay, I'm dividing all by x squared. If you look at here, again, I will have limit of x as this approaching to negative infinity. X cubed over x squared is equal to x. And again, x squared over x squared is equal to 1, plus this one remains as it is, 1 over x squared. Again, limit of 1 over x squared as x is approaching to negative infinity. For this one is equal to 0. And limit of x as x is approaching to negative infinity, that will be negative infinity. So in general, what did I get? I got 1 minus negative infinity over 1. Negative infinity over 1 is equal to negative infinity. Again, is negative infinity a number? No, it's not a number. We calculated x, the limit of the function as x is approaching to infinity, and we calculated the function limit of x as this approaching to negative infinity. In both of the cases, I didn't get any number. So in general, okay, we say that f of x has no horizontal asymptotes. Okay, since we didn't get any number from both of the cases. Okay, let me write another example for you. These examples are not in the course material. Only the first example was in the course material, okay? Okay, another example about that. Again, find the horizontal asymptotes of f if exists. If it exists, if exists, however you're saying it. Okay, f of x is equal to, for example, x over x squared plus 3. Let's say that. Okay, let that one be 2x squared plus 3. Again, we are finding the solution for this one. What shall we do? Limit of x as it's approaching to positive, negative, infinity. I will do both of them in the same case because I will get the same result. Okay, again, if you look at the power of the denominator, okay, we said when we are calculating limits as x is approaching to infinity or negative infinity, what do we have to do? We have to check for the highest power in the denominator. I don't care about the numerator. Okay, what's the highest power in the denominator? It's x squared. Since it's x squared, so I'm dividing all of the terms by x squared. What do I get from this one? Limit of x as it is approaching to positive or negative infinity. X over x squared is 1 over x. 2x squared over x squared is equal to 2 plus 3 over x squared. Okay. If x is approaching to infinity or negative infinity, if I input it in here, that will equal to 0. Limit of this one is again 2 because it's a constant number, and that one is also 0. So what do I get in general? 0 over a number. What is 0 over a number? That's equal to 0. Is 0 a number? Yes, of course, 0 is a number. So that is when I calculated the limit of the function as x approached to infinity or negative infinity, I got 0, and 0 is a number. So y is equal to 0 is a horizontal asymptote for the function that we have got. So what do we have? We had 3 cases. Either you're getting a regular number, positive, negative, or you're getting 0, or you're getting positive or negative infinity. Okay? That was about horizontal asymptotes. So how do you find a horizontal asymptote? We are given a function, okay? We are finding the limit of the function as x is approaching to infinity or negative infinity. And that will be the result of the, if we got a number, that will be the result of the horizontal asymptote. Okay, let's move to vertical asymptotes. Okay. So a vertical asymptote, let's write the definition of it. Vertical asymptote, a line, or the line x is equal to c. In the horizontal asymptote, we said the line y is equal to a number. Here we say the line x, okay? For the vertical asymptote, we say the line x is equal to c. It's a vertical asymptote. It's a vertical asymptote for f of x, okay? That's equal to y if either, okay, so any one of them, okay, limit of x as it is approaching to c from the positive side or from the right side of the function f of x is equal to positive or negative infinity, okay, or I'll find the limit of the function f of x as x is approaching to that number c from the left side is equal to positive or negative infinity. Look, I'm saying positive or negative. Of course, you will not get positive and negative together, okay? So it is positive or negative infinity. So if you look at that definition, what will we get? What do we understand from this one? I'm given a function, f of x, that's equal to y, okay? How do I find the vertical asymptote of that function? I have got a number c here, okay? In the horizontal asymptote, I had infinity or negative infinity here. But here, when I'm calculating vertical asymptote, I'm having a number c here. I'm approaching it from the right side or the left side, okay? And if the result was infinity, I will call that number, okay? I will call that number a vertical asymptote, okay? In horizontal asymptote, what did we have? We had limit of x as it was approaching to infinity or negative infinity for the function, and we got a number b, okay? Here we were approaching to infinity or negative infinity, we were getting a number, but in vertical asymptotes we are approaching to a number and we are getting infinity or negative infinity. Okay, so how is the procedure for finding those vertical asymptotes? In example 3.31, it says determine the vertical asymptotes. I will write it shortly, okay, for f of x that's equal to x squared minus 9 over x squared plus 3x. So a function is given to me. It says determine all the vertical asymptotes for that function, of course, if it exists. Let's do the solution. In horizontal asymptote, asymptotes, we were directly starting with the solution, finding the limit of the function, okay? But in vertical asymptotes, we have to first find those numbers that makes the denominator equal to 0. Okay, let me write it for you. First, find all those numbers that make the denominator equal to 0, okay? And then when we're finding those numbers, we're finding their limits, okay? So let's find those numbers that make the denominator equal to 0. What do I have in the denominator? I have got x squared plus 3x. I'm finding those numbers that makes it equal to 0. So what do I get from here? That's a quadratic equation. I'm simply solving it. What do I have common between those two terms? I have got x from here and x from there, so I'm taking an x out. What remains here? An x remains here and 3 remains there, and I will get equal to 0. I've got two things multiplied to each other, the result is equal to 0, so either that one is equal to 0, okay, x is equal to 0, or x plus 3 is equal to 0, okay? So here x is equal to 0, or x is equal to minus 3. That's linear equation. Simply I'm taking the 3 to the other side, so I will get x equal to 3 as the number that makes the denominator equal to 0. Now what did I get? I got two numbers, x equal to 0 and minus 3. Those two numbers make the denominator equal to 0. Look, if I put 0 in here, I will get 0 for the denominator, and if I put minus 3 into here, I will get the denominator also equal to 0. Now I'm finding the limit of the function as x is approaching to 0 from left and right, and I'm finding the limit of the function as x is approaching to minus 3 from left to right. Okay, but I will squeeze give it a shortcut to those solutions because that will be 4 different cases, but I will do it in 2 different cases. Okay, so let me find the limit of the function as x is approaching to 0. Limit of the function x squared minus 9 over x squared plus 3x as x is approaching to, that's the second step, okay? That was the first step, finding the numbers, and then the second step, I'm finding the limit of the function for those as x approaching to those numbers. Okay, first we said 0, so I'm approaching to 0 as from the right and from the left. Okay, let's solve that equation, I mean that limit. How do you solve a limit as x is approaching to a number? We have studied this one. We are looking at numerator and denominator, finding factorizing it, I mean x approaching to 0 from left and right. If I factorize the numerator, what will I get? X minus 3, x plus 3, you know these ones, that factorizations. And from the denominator, I have got what? I have got a common factor x. Then what remains here? X plus 3. If you look at numerator and denominator, what do I have? I see common factors, x plus 3, x plus 3. So those two terms cancel each other. Now, what has remained here? That remains here, limit of x as it's approaching to 0 from left or right, x minus 3 over x. If I put 0, okay, if I, let me do like that. If I approach that function from the left side, what do I get? I will get negative infinity or positive infinity. And if I approach from the right side, I will get negative or positive infinity. So I will get what in general, or generally talking, I will get positive or negative infinity. Okay. If I put 0 from the right, for example, if I input 0.1 into here, we'll get negative over positive, that will be negative infinity. And if I approach from the left side, I will get positive infinity. So what did I get? If you look at here, okay, I approached from the number and I get positive or negative infinity. So what will I call that number? That number 0, I will call it vertical asymptote for that function. Okay, Let me write it here. So since I found the limit of that function as x is approaching to 0 from left or right, and I got the result is infinity, so x is equal to 0 is a vertical asymptote for f of x. Okay, now we are done with x equal to 0. Now I have to try with minus 3. Okay, that's page number 13. I have to find the limit of that function, limit of x, where was the function? Okay, there, x squared minus 9 over x squared plus 3x. What do we have to calculate this time? I have to calculate that limit as x is approaching to minus 3 from right or left. Okay, as I told you, I'm doing it as one step. You do not need to separate it because I'm getting the result of it. Now, if you look at this one, again, I have to factorize the numerator and denominator. So x approaching to negative 3 from left and right. Factorizing this one is again x minus 3x plus 3. Okay, all over what? All over x, I'm taking it out again, x plus 3. Okay, again, what do I see in common? I have got x minus 3 and x minus 3 common, so they are canceling each other. What is remained here? X approaching to minus 3 from left to right. X minus 3 is remained in the numerator, and denominator is x. If you put minus 3 into here, what will I get? Minus 3 is equal to minus 6. If I put minus 3 into here, what will I get? Of course, minus 3. What is the result of this one? Minuses cancel each other. Okay, 6 divided by 3, I got 2. Okay, if you look at that 2, is it infinity or negative infinity? No. Okay, that 2 is not equal to infinity or negative infinity, positive nor negative infinity. So we say what? So since the result is not infinity or negative infinity, we say that x is equal to minus 3 is not a vertical asymptote for the function. Okay, why? Sorry, not. Oh yeah, minus 3. So why minus 3 is not a vertical asymptote? Because if you look at the definition, we said that number, okay, will become a vertical asymptote if the result is positive or negative infinity. But if you look at here, when we found the limit of this function, what did we get? We got 2, where 2 is not equal to infinity and minus infinity. Since we didn't get that result, so I say that that number, okay, that number over here is not a vertical asymptote for the function. Okay, that's all about vertical asymptotes and horizontal asymptotes. Okay, I hope you've understood that section. I'm moving to section 4. Okay, chapter 3. Section 4, it's about optimization elasticity of demand. And section 5, it's about additional applied optimization. Okay, section 3 and 4, 3.4, 3.5. For now, just for now, okay? For now, skip those two sections. Why? Because if the classes are opened again, if you I can explain those ones, it is better to explain those two sections in the class, because these ones are word problems. It's not just mathematics that I can do it step by step for you here. I have to give more explanation. We have to have like equipments to make you understand better. If the classes were open again, I will explain those two sections in class. If not, I will try my best to explain those sections just like that, okay, to make you understand. So for now, leave those two sections, and we are done with chapter 3. Okay, chapter 3 is done. So what did we have in chapter 3 over in general? In section 1 we were talking about increasing, decreasing functions. In general we were using the first derivative. In section 2 we were talking about concavity and inflection points. We were doing the procedure on the second derivative of the function. Section 3 it was about asymptotes, okay, as we've explained it today. Section 4 and 5 we've skipped it for now. Hope you've understood all of the subjects in chapter 3, and bye for that chapter. I'll be doing chapter 4 for you later. Have a good time.